Welcome to today's lesson. I'm Semasaka Kilian Dens. I'm going to take you through a lesson on more concepts. And so, as I indicated, today we are going to look at more concepts. We are very familiar that when we are dealing with more concept, we need to familiarize ourselves on how we can actually do calculations based on the quantities given. And so basically I will just give some steps which are not cast in concrete, but can help to try and remember exactly what you're supposed to do when you are exposed to a question on more concept. The first familiar thing that you need to do is, first of all, actually to be able to write the chemical equation. If it involves that you are supposed to write an equation, and so you're supposed to write as such. And the second is that the equation that you write, you are supposed to balance it. After balancing the equation, then you can now answer what is actually being asked. And so I have a question here. There is actually a question on ethanol, which is undergoing combustion in oxygen. And so it yields carbon dioxide and water. And so this is the equation which was given. At times they cannot give you the actual equation. So we are lucky here, the equation is already actually given. And so the first part of the equation is that they want us to balance the equation. And so the first part, as we have indicated, we have ethanol, which is actually a liquid which reacts with the oxygen. This one is actually burns in oxygen, which is a gas. And then it liberates or yields carbon dioxide, which is a gas. And then water in form of water vapor as a liquid is produced. And so when we are asked to balance an equation, we are actually looking at the number of atoms for each of these elements. And so we can start with the carbon here. You notice that the number of atoms in the ethanol is actually 1. It's 2 actually, there are 2. And then you balance it from the right side, and you notice that here there is only 1 actually carbon atom in oxygen. And so we're going to write a 2 there for us to balance that. So meaning that now we have 2 atoms of carbon on the left side and 2 atoms of carbon on the right side. We look at hydrogen. Hydrogen here, we have 6 atoms, which is 5 plus 1, 6. And this side, you notice that we have only 2. So to make them actually 6, we can add 3 there, which is 3 times 2, 3 times 2, which is actually 3 times 2, which is actually 6. So you notice that here we have balanced up actually oxygen, because hydrogen, we have now actually 6 atoms of hydrogen. Even this says there are 6 atoms of hydrogen. And then we go to oxygen. Note that oxygen here, we have only 3 atoms, 1 plus 2, which is 3. And yet this side we have actually 2 times 2, which is 4, plus 3, 7. So we need to put 3 there, so that this becomes 6 here, plus 1, 7. And you note that this is now a balanced equation. It means that we have answered the first part of the equation. The second part of the question is that they want us actually to calculate the mass of oxygen needed to react with 5 grams of ethanol. So in other words, what they are saying is that they want to know how much oxygen in terms of grams is required to react with ethanol if 5 grams of ethanol actually react. So for us to be able to know exactly what is required for each of them, we can look at the mole ratio. You notice that here, actually, ethanol is 1 mole, while oxygen here, there are 3 moles. Then carbon dioxide, there are 2 moles, and water, there are 3 moles. And so this is the mole ratio based on the balanced equation. And therefore we have been told that actually we have 5 grams of actually ethanol. So they want us to find the number of grams for actually oxygen that should react. Okay, and therefore we are familiar that moles is equal to mass divided by molar mass. In our case, we want to find the mass for actually ethanol divided by the molar mass for ethanol, which gives us, we have been told, there are 5 grams divided by carbon has actually 12 atoms multiplied by 2 plus the hydrogen actually 1 multiplied by 5 plus oxygen 16 times 1 atom plus 1 hydrogen atoms multiplied by 1. And so this gives us actually 5 grams divided by 46. 46 grams per mole, which gives us actually 0.1087 moles. So these are moles of ethanol, and therefore we can look at the mole ratio of ethanol as we indicated, which we said ethanol mole ratio with respect to oxygen. We said they were in the ratio 1 to 3 from the balanced equation. And we have found the number of moles, it would be 0.1087 moles, which would give us actually X number of moles. And therefore the number of moles for oxygen would be actually 3 times, which is 3 times 0.187 moles, which is equal to actually 0.3261 moles of oxygen. And therefore, for us to be able to find the mass, we are aware moles is equal to mass. Now we are looking for oxygen divided by the molar mass for oxygen. We have found that the number of moles here is 0.3261, which is equal to mass over, and you notice that here it is 16 multiplied by 2, which actually gives us the mass of oxygen would be actually 32 multiplied by 0.3261, which gives us actually 10 0.4 grams. And so meaning that we have calculated the number of moles for oxygen. That equation, they want us to find the mass of carbon dioxide produced when 5 grams of ethanol is burnt. We are aware that now I have to look at the mole ratio for ethanol with respect to actually now carbon dioxide. We note that from our balanced equation, if we go back to our balanced equation, it is shown that actually 1 mole would yield actually 2 moles of carbon dioxide. So this one will be 2 moles. And you remember, we already calculated the number of moles here, which we found to be 0.1087 moles. Meaning that for us to get the number of moles for carbon dioxide, it will be actually 2 times. It will be 2 times 0.1087, which is actually equal to 2 multiplied by 0.1087. 0.174. Zero point 174 moles. So these are the number of moles that you produce for actual carbon dioxide. For us to find the mass of carbon dioxide, it means that we have to actually multiply the number of moles for carbon dioxide multiplied by the molar mass of carbon dioxide, which gives us actually 0.2174 moles multiplied by actually 44 grams per mole, which gives us actually 9.6 grams of carbon dioxide produced. So I thought we can go through these lessons so that you can familiarize yourselves with the actually more concepts. Thank you.